VGA one. Here's an HDMI one.
Oh no, that's too fancy for me.
All right. Some of the other places have HDMI.
Our 2008 laptop is not long for this world. It's an office space kind of thing is going to happen in December. I'm getting a new computer. Actually, my wife, we have a dishwasher that's temperamental. And that was the one thing my wife said. She's like, "Can we renovate this house? Can we totally office space the dishwasher?" And I was like, "Seriously?" She's like, "Yeah." I'm like, "So good." All right.
No, come on. All right. There's a lot of stuff up here.
I know. Like, I have sodas, I have waters for the presenters.
Oh, no, I also know. Did we already get a note taker?
Oh, yeah. All right, we're getting rounded in on that time where it's time to start this process. So if you grab your seats. Kind of shocked that our editor's in here, but you know, I'm sure he'll be on his way. So, welcome to IETF 97 in Seoul. This is the TLS working group session. If you thought you were supposed to be somewhere else, you probably should go. No, I thought you were supposed to be at mine. Oh, okay. So,
Yeah, get closer.
am I closer? Okay. So, TLS working group session. Number 1. Second session is on Friday. The note well, note thee well. Gangman style. So basically the brief summary, if you haven't seen this yet, is that any contributions you make, if you had no of IPR, you disclose them. This isn't the actual rules, there's a link to them. If you have any questions, ask. You should know that you are being recorded and you are being broadcast. So there's not maybe going on. Any questions? Probably get to the mic first. So the next thing we need is a Jabberscribe and some minute takers. We have a Jabberscribe, we have a minute taker. Jim, are you doing the minutes on Etherpad? So there is an Etherpad later. There'll be a link to it. If you want to help, you can click on that and add as you like. There's some blue sheets circulating. Please make sure to put your name and your affiliation on there. These are new, some reminders. Basically state your name at the mic for the scribes and the minutes. And also, I've seen other SDOs do this, and I think it's probably worth stating here. I think we should probably keep it classy at the mic and keep it professional. So, agenda bashing. This is for Tuesday, and we have another session on Friday. So basically, we're doing the administrative right now. Then Joe and I will run through some document status. Then we're going to have Rich give a quick update on OpenSSL status, because I'm sure you're all definitely interested. We have 95 minutes allocated for TLS 1.3 related sessions. Then we have some presentations on TLS visibility inside the data center with Steve, sorry, and Jason. I'll fix that later. About 20 minutes, let's see how that goes. Explorer authentication in TLS, aka post handshake auth. Nick Sullivan is going to get up and present, kind of a morphed idea. And then on Friday, we've got a whole bunch of other stuff. Basically, it's another placeholder for things that we maybe didn't get through today, and this rebranding issue. So basically what's going to happen is if we do get through the TLS stuff today, I'm going to pull the rebranding thing forward so we can do that today. Then we have a presentation on DTLS that Hannes is doing, that Ecker might channel, depending upon when we do it. And then we have other active drafts in the working group is a DNS validation chain extension that is going to stay on Friday. I checked with Melinda. She not going to be able to get slides done yet. Same Nick's slides as well are also going to stay on Friday because he hasn't had a chance to do those. Martin's example handshake traces for TLS 1.3 is 5 minutes. He has no slides. If we have time, we're pulling that forward because it's related to DTLS. And then we have a bunch of docs that have been kind of like in holding. And so we're going to try to talk about those today if we can. If not, we'll discuss them on Friday. And then we have some other presentations, time permitting, on server identity pinning with tickets and optimizations of the Internet of Things. So that's kind of the order. So basically, it's going to be kind of fluid. I will update these as we go along, and we'll see how it goes. So basically, we're going to agenda bash on the fly. Does anybody have anything else that they would like to agenda bash? Great. Doc status. We published 3 RFCs since the last time we met. That's awesome. Yay. A lot of them took a long time, cached info. I think it was in the works for a decade. So I'm really glad to see that that got done. Hey, Hannes. Right now we have TLS 1.3 is in working group last call. We also have this elliptic curve cipher suites for TLS 1.2 and earlier, where we're in the process of uplifting it from informational track to standards track. And I guess that I'm curious to know, Yov, if you think that we're ready to go out the door with this one.
Well, yes, Sean, I think it is ready for working group last call. There is one outstanding issue that we have to decide what we're doing with Edward's 448 context, and which I think we should just pass the empty string like everybody else. This same subject came up in IPsec.me just an hour ago, and it's going to come up in Kernel on Friday. And I think we should all come up with the same answer. Otherwise, some people will be very surprised.
Yes. So I think that that's really great. But I think what we probably can do is even last call it with the caveat knowing that that's the one thing that's open. So that's great. We have this other draft, which is adding some PSK cipher suites for ASGCM and ASCCM. Daniel, are you in the room? You can't tell I didn't rehearse this at all. So I was going to ask Daniel and say, Daniel, is this draft ready for working group last call? And then he was going to get to the microphone and say, yes, I think it is. So basically that's what's going to happen. So really what the slides are going to look like this at the end of the week. We're going to have 3 documents in working group last call to kind of get the process going. And that means we'd only have hopefully only one active working group draft by the time we get to Chicago, because hopefully TLS 1.3 will be out the door, and we'll talk a little bit about that later. The next thing is this little uplifting thing from informational to proposed. One of the things, I sent a message about this to the mailing list. This is purely housekeeping, and if you don't care about process, you need not listen. The idea is that it's informational now. We want to move it to standards track, much like we are doing for the elliptic curve cipher suites for TLS 1.2 and earlier. Because there is no errata on this draft, we can pull some process. We can basically do an IETF last call that says we are uplifting this. It's 4 weeks and we're done. So my plan is, unless somebody objects violently on the list to this process, that I'm going to get that started probably next week by telling Stephen. You object. Yeah, fine. But at least we won't have to actually do any editing documents. So we're supposed. So what Russ is saying is that a new RFC is going to pop out regardless, because the metadata needs to be updated in the header, which sucks, but that's life. But we'll get through the process. One of the new drafts that's going to get added once Joe and I have time is to add the DTLS INA registry updates document as a working group draft. Now, this one's a little weird because we're the chairs and we're the authors, so Stephen is kind of running the process. But basically, this is a collection point for all of the updates that we're doing to the DTLS registries. And then TBD, we got a bunch of documents in the TBD section, and we're going to go over those later. That's the other documents part. So that's it. Good. You want anything else? I know I rifled through that. All right. So now we're going to jump into OpenSSL status. Rich.
Okay, Rich Sauls. I work at Akamai and I work at OpenSSL, and both on OpenSSL for Akamai. Both those things are kind of important. Next slide. I promised to talk at like a significant fraction of an acre to get done in time. So on the OpenSSL side, yeah, I'm too short. It doesn't matter. Okay, so all dev work in OpenSSL is now being done on GitHub, which means that there won't be big, large changes just sort of suddenly appearing. And we're starting to see more community feedback there, so that's a really good thing. OpenSSL is committed that the next release will be, what did I say, 1.1.1, which is API and ABI compatible with the release we just put out. We've done nothing up until about 2 weeks ago. We've done nothing on TLS 1.3 because we were busy getting this other release out. There's going to be a whole bunch of internal changes, but they'll all be hidden because, for example, all the data types are opaque. OpenSSL is also committed to say that TLS 1.3 is the primary, if not the only, deliverable in terms of features, as opposed to the usual bug fixes, in the next release. We're planning a specific interop date, a specific release date, which is unusual for open source. And the reason why we're doing it is because, wearing my other hat, we are paying OpenSSL to commit to a date with known interop. And that stuff will, as the contract's negotiated, that stuff will come out over time, but it's sort of all the usual suspects, like the current set of TLS 1.3 implementers, more or less. Next slide. So what we've got so far, TLS 1.3 is understood as a protocol. Underneath the covers, it's TLS 1.2, because we haven't changed much. Supported versions is done. The secret generation, the HKDF, all the key generation and recycling and all of that, and all the parameters to step the keys, that's all done. We renamed whatever it is, supported curves to be supported shares. We support the key share support is in the pipeline. It'll be checked in shortly. And then I think perhaps the biggest thing is we are now able, or soon will be able, to run the boring SSL test suite. We also have a mechanism for running other tests outside of OpenSSL. So if you have a TLS 1.3 suite, or you have applications that are interested in using TLS 1.3, ping me. And that's it.
Under 5 minutes. Excellent. You're up next, Decker. I have water for the presenters as well. Okay.
All right. Next slide. So here's the agenda for this presentation. Next slide. So where things are, obviously we're working group last call. It ends the 20th. We now have quite a few interoperable implementations. They're not OpenSSL yet, but hopefully soon. Right now, the two major browsers that have done this, Firefox and Chrome, both have this on or quasi-on in their nightly releases. Firefox has it on by default. I believe Chrome's running an experiment where about half the people get it. And those are both draft 16. And I lie about this. We now have draft 18 in both NSS and boring SSL, Cloudflare's implementation, and also Mint and Fizz. And although I think Fizz isn't live on the real internet yet, I wish I and boring SSL just landed 18 as well, like about 10 minutes ago. So that's good news. And we have, and TLS, I forgot. I apologize, I should have up there. And a bunch of other people are doing stuff. You can as a free advertisement, if you get a Firefox nightly or Chrome, the 50% probability, you can go to cloudflare.com and get TLS 1.3. Next slide.
So just point of clarification here. So I'm basically going to be using this in the Shepherd write-up when we give this to the ISG to be like, hey guys, thank you for your comments, but we kind of already have interoperability with multiple people. So
that's a good plan.
Okay, so the more you keep this up to date, to make it easier, that
we will do so. Yeah. And I mean, to give you a sense of what we do, at least at Mozilla, we run our code in CI against Google's, like when we do commits. So we have some level of confidence that we haven't screwed up. Next slide. So here's the interop matrix from the hackathon. Things in green are things that work. Things in white are things that we haven't tested. Things in gray are things that don't make any sense, like things that are like having server-only implementation, try to talk to clients. The notations here are things in blue are self-tests, obviously. The notations here are which features we tested. So the bottom line here is we have like extremely good interop at 1 RTT. we have some zero RTT interop and a fair amount of of resumption interop. So, and we're finding. I'd be happy to hear from David or Richard or Subodh and Kyle or whatever, but we're finding some ambiguities in the spec, but I think by and large things we're finding to be pretty clear, and mostly when we actually find a defect, you can go back and look at the spec and be like, no, that I'm wrong, you're right, or vice versa. Next slide. Okay, so there were a few issues raised in the last call. I'm going to discuss them in no particular order other than the order I happened to pull them off the tracker. The first issue is this supported version stuff. So the way that text currently reads is that if supported versions is present, it's the exclusive mechanism for negotiating versions. And I think there was general consensus that was a good way to design things, but the confusion is that the current specs tells you to list every version which you support in supported versions. And so in particular, say you're a 1.0 through 1.3 client, you list 1.0, 1.1, 1.2, 1.3. And so this has the odd situation that in principle, at least one could have TLS 1.2 and legacy client and legacy version in the client hello, and then end up negotiating 1.0 if the server had crazily only turned on 1.0 and 1.3. There was some debate on the list about whether this was a good situation, and a bunch of proposals. So I think there are basically two possibilities as far as I'm concerned. One is leave it as it is, which I actually think is fine. The other is to leave it as it is, except clipping the minimum implementation at 1.2, with the assumption being that if you're offering 1.3, either you should be offering only 1.3, or you should be offering 1.3 and 1.2, but you shouldn't offer 1.3 if you only support 1.0 and 1.1 as well. And the way you would do that is you'd forbid the client listing any value less than 1.2, and the server would simply ignore any value less than 1.2 if you give it to it. As I say, I don't feel very strongly about this. I think Matt Caswell and Brian Smith felt sort of quasi-strongly about it. It's fraction, it's slightly more code to execute, but almost none. So I'd like to get the sense of the room of how people think we should behave here. Yeah, I had the same kind of shrug face David just made. So
David just made an interesting shrug. Kyle.
Kyle Neckritz. Just to clarify, in a supported version extension, why do we need to list 1.2 at all? Isn't it less than 1.3 in the second proposal?
Right. So the no, because suppose you support TLS 1.2 and you support draft 18. When you have some way to negotiate 1.2 and we support incompatible drafts.
Well, I think you could just fall back to the old negotiations.
You could, but yeah, there was some feeling that once you got into, the way our code works is if you give me supported versions, I ignore the thing that was in legacy version completely. I think that's how boring works as well.
So I guess my feeling is there's not a bunch of people lining up at the microphone, and what we should do is, now they are great. It worked. My plan worked.
Yeah. So Martin Thompson, I don't really find the arguments for this change particularly compelling, particularly when you actually write the code and have it sitting in front of you. It's actually kind of clumsy dealing with the proposal, because you have to look at supported versions if it's there, and then if you find that you don't support any of those ones, then you have to go back to the old negotiation.
Oh no, then you fail. No, then you fail. So the way you write this code is right now. If you look at our code, we basically do an iteration of every version we support from max to min, and what you do is you'd PR min. Sorry, you PR max 1, 2, and version min to make it work.
Right, and then you would not send the extension at all if that set were empty.
You wouldn't have that. You wouldn't send the extension unless 1.3 was on. So that guarantees the set is not empty.
Right. Okay.
And then on the server side, you would as usual choke if there's no overlap.
Okay.
I gotta say, it's not much more complicated to do.
No, it's okay. Yeah, I hadn't thought it all through. Obviously, I can live with that. I can live with it either way.
It's kind of yeah.
We could save some bytes, but who cares about that?
That's the whole reason we're here. We don't care which one it is as long as it's something written down. The advantage, one of the arguments, and I'm not sure which side it falls on, is it makes it pretty easy to have the same code be a test harness where you just specify the versions on the command line. if you allow old versions. On the other hand, allowing old versions and only old versions seems kind of gross. So whatever.
I mean, it seems like if there are people that strongly care and you think it's not that hard to do, maybe we should just adopt it. If nobody's arguing vehemently against it.
Just to clarify, Matt Caswell on the dev team is working on a lot of the stuff. He doesn't really care. He just wants an answer.
Okay. I mean, I guess it's slightly easier textually just to clarify the current text, but yeah.
Let's do that. Then.
Okay.
Let's just,
Next slide. That's a very good slide. If you could see this slide. Right. Okay. So when we went to implement exporters, we found this modest little defect in the spec. This would actually be a wire format change. The way exporters are defined as invoking each KDF expand label, but they use the context string in the slot in the third positional argument, which is named hash value, and but it's just an arbitrary string. It's not a hash, and so that's sort of slightly irritating for consistency, and it does mean that it doesn't mean you couldn't have. It means that if you want to have like a nice long context, you'd have to explicitly hash it first, which you otherwise might not want to do. Again, this isn't like a crisis because like no current exporter is defined as taking a context bigger than 255 octets, and those exporters could always be defined as having a pre-hash. But it seemed like it might be nice to actually be consistent about things that we claim were actually hashes. So at the cost of one hash, I'm proposing to make this change here. Okay, I will make it happen. Next slide. Okay. Right. So when we used to have this sort of simple structure where clients actually really couldn't say much, really couldn't do much of anything when they gave certificate authentication, and like couldn't give you SCTs, and I don't think could give you status information either, really. And then we adopted some PR, which number I don't remember, by Nick, that basically made the certificate message from the client have like a pile of extensions in it, just like the certificate message from the server, and that. But however, that raises the possibility that those extensions could contain like SCTs in them, and or status or whatever. And when you read that text, it like says like, you know, as usual, like you can't send anything in an extension and certificate that wasn't sent in client hello. That's like completely incoherent because the client says I'm going to send an SCT, and then he sends it again later. So the right place for the server to say I'd like you to send me an SCT or not send me an SCT is in certificate request. So that doesn't require any change in the certificate message, but the problem is the certificate request message is defined as having extensions, but those extensions are just OID filters. They're not, even though they're called extensions, they're OID filters as opposed to regular extensions. So let me, so I think the thing I feel strongly about is that we should do something about certificate requests that you can put like genuine TLS extensions in there that say things like, please send me an SCT, or I guess more likely, please don't send me an SCT. But we should do something here. And then there's a bunch of like questions about exactly how it's spelled, but I think we should do approximately this. And this wouldn't be a matter of removing the existing functionality for having OID matching. It's simply a matter of restructuring things so that could coexist with, please send me an SCT. Is anybody bent about that? I can show syntax, but if people think it's conceptually stupid, then we should have that discussion.
So OID extensions would be, the OID matching would be an extension in that.
There are several potential approaches, which I'll show how to spell it in a minute.
So are the OID matches actually, did we settle that the OID matches are just guaranteed to be exact literal matches? As I remember, the OID matching was done differently depending on what the OIDs were.
That's correct, yes.
So, okay. I mean, you could just make up a new OID and call it.
You could make up a new OID, but that seems like, given that we already go into the trouble given that you want to use the SCT code, the code points for SCT and status requests, like it's weird to pack them into some OID.
because I mean, we stuck this stuff in for Andre, right?
No, and we're not trying to remove it.
No, I'm trying to make sure, like,
Yeah.
if we make a change, it's still.
Andre's right there. He'll scream if we didn't get it right.
All right.
So there are a number of possible ways, as David would say, to spell this. Next slide. The specific way I propose to spell it, which you might not like, is so I've just taken the thing that used to be called extensions and renamed it OID filter, which I'd be happy to name to something else. And then I've taken the thing that I've taken the slot that was called extension, that was called like certificate extensions. I guess it's still called certificate extensions, but it used to take like these new extensions that had whites in them that are now called light filter extensions, and now it takes regular extensions. And then all we're going to do is we're going to define like basically a code point that says here's the extension containing my OID filters, and you'll put that in or not put it in as you please. This creates a level. You might say, well, why didn't I just create an extension called like OID filter and have like an OID and an extension one at a time? The reason why the reason why you don't do that is that you're only going to have one copy of an extension in any setting, and I didn't want to break that change, to break that thing. So as I say, the number of ways that this is the sort of minimal change. A number of people proposed, at least one person, I think it was David Benjamin, proposed that we should instead have that we should no longer have the primary key be OID for these things, but have the primary key be code points we assign, which then map to OID. That would also work, but I'm less enthusiastic about it because it seems like more of a pain in the ass. This is sort of the minimal pain in the ass change. There's one more thing you could do, which I should mention. I may have another slide about this actually. Yeah, right. So other possibilities you could do are place the OIDs with extension IDs and flatten the list, or have two lists, the OIDs and the extensions. So I mean, like these seem like entirely like aesthetic questions about how to spell this. So I'm open to having an aesthetic debate, but I think these are unless someone has a strong opinion, I was going to do it this way. The other thing I propose to do is, since we're in here, is to define certificate authorities as a new kind of extension, because like nobody usually uses it, not nobody, but many people offer certificate request and do not in fact offer certificate authorities in the certificate request. And so having this field, which is like a static positional field, which is generally empty, strikes me as extraordinarily silly.
Yeah. So Martin Thompson, I think this is also a good idea. I recently discovered that NSS in some configuration sends 300 kilobytes of distinguished names when it sends a certificate request. Anyone who's discovered that their servers are sending them massive certificate requests, sorry. We've turned. Yeah, I think it's others.
It's a special present from us to you, Dan.
But we haven't turned it off. We just turned it off in one of the places we discovered it. So expect to see more of those. But I think this is the right thing. The number of times that we actually see people really using distinguished names for selecting of certificates is actually kind of marginal. Most of the time it's just, give me a certificate, I'll take anything you've got. And most of the time people actually understand what that means. I think this is...
Yeah. I mean, so we're not...
This is all the web PKI roots. We're not...
Yeah.
We're not proud of this, right?
We're not making it substantially harder to do this. It's just a matter of like, you got to like read one more length byte, basically.
Right.
Yeah, Ben Kadek, I was just wondering if we had computed how many bytes we save or lose because of the respelling.
I haven't, but I mean, I think we because, well, no. So in the most trivial version, I saved you 2 bytes. In the version where you didn't, in the version where all these fields were empty, I've saved you 2 bytes. Okay. Great. I will do that. Okay. So this is sort of
Kyle and Chris, is there any reason not to move the signature schemes to the extensions as well, just to be like the rest?
We could do that. I wouldn't, actually, it might make the implementation slightly simpler. Okay, Martin's saying yes, so I'm on board with that. Move signature schemes to extension as well, so we don't have to, that actually makes sense. Because we can use the same extension processor we use, it'll save a tiny bit of code. Yeah, okay. Right, this is a pre-clearance for a change. Ever since we screwed with, ever since we just like screwed with the record format, it's been like kind of annoying that we have these 3 bytes at the beginning of the message, which always have to contain 230301. And that's like kind of waste, and milliseconds of money and all that stuff. So we'd like to get rid of it. There have been some questions about interop, and the interop question is not servers because once you get to the point where you're sending the new encrypted record header, what the server is doing. This is only about the encrypted header. It's not about the plaintext header. So the server will take this, is no problem. But there's some concern about passive analytic tools. So I've been promising for quite some time to actually do a measurement to see if this actually breaks anything, and I finally got my measurement infrastructure up this month. So sometime between in the next month or two, I can actually take a measurement to say if this is going to be a problem or not. So what I'd like to get is like working group approval that if I come back with a measurement that says like this is not a problem, and of course you can make your own judgment then about what the data actually says, that we don't argue about like whether the technical change is correct. So I've got a PR here. I think number 762. There's one tiny little technical wrinkle which you need to be aware of, which is that if you're doing an HRR, if the client did 0RTT and you're doing HRR, you now have to basically scroll past like all the encrypted stuff, which has the new header format to get to the clear text client hello, which is the old header format. And so the problem now is that because the length is in an unobvious place, basically you're kind of confused with the status. The good news is that we require records to be no longer than 2 to the 14 plus or minus bytes, and so the top bit is always 0. And so if you just use the top bit to basically be on the new record header format, the problem goes away. So I have a PR for this. I encourage you to take a look at it. If you think this is screwed up and not good, then now's the time to say so, or after you read the PR. And I won't be merging it without some other message to the list saying like I prefer to actually merge it. But it'd be nice if like people think, so if for instance you look at this and you're like, on reflection, I've looked at this and this is the world's terrible idea, then I won't bother taking any measurements, right? So.
I think it's fine. Just, obviously make sure that you have the first bit set when you do the measurements.
Yeah, good point. Thank you. Okay.
Anybody else have any concerns?
Okay.
All right.
Next slide. Right. So Quinn sent this message to the list a couple days ago. I think it was you, wasn't it? Yeah. So we had an extended thread about about what the limits for ASGCM were. And I thought Quinn might. Here's what he said. There's no point in restating it. He's here. If you'd like an opportunity to make your case, this is your opportunity to make your case. I guess I don't know the chair. I really defer to the chairs on how to manage this particular question. I'm just processing issues as they come in here. So I guess right.
So I think we've had discussion on the list.
Right. So I guess my question is: anybody persuaded by this? And do you want to jump to this argument and say we should revisit the limits?
In some respects, I think this is, not being a cryptographer, this is almost editorial that we could proceed forward. And if sometime later we decided like, oops, no, we need to change this number higher or lower, we can do that. I don't want this to be a gating thing on us not proceeding.
It isn't. I just thought like we have a face-to-face opportunity to discuss this, and so I was trying to take advantage of it. But if because I felt like Quinn and Kenny had an extensive discussion on the list, and they didn't come to consensus. And unfortunately, Kenny's not here. But I thought maybe an opportunity to like actually come to consensus. But
yeah. So Martin Thompson, we discussed this quite a bit, and we had Kenny and a bunch of people. I think Watson and a bunch of people who actually know what they're talking about look at this pretty carefully when we put the text in. And having implemented it, I see no reason to change it. I've looked at the analysis and the numbers that we have. Yes, they're arguably super conservative, but I have no problem with that.
Because ASGCM is the MTI, right? It's
Yes.
the mandatory to implement. Okay.
I think we had discussion after the text, had been put in, not after the discussion.
I can't recall what order I did things in. I may well put the text in prior to discussion.
I remember I started the conversation after I read the draft.
That could easily be the case. I apologize if I got ahead of consensus. I'm more than happy to change the numbers if they're working with consensus. That's really for you guys to manage.
We'll put that on our queue.
Yeah,
'cause-
I think we'll have to go back and look, but I think my recollection was that there was, maybe not this specific text, but there was discussion of this topic, and the text came from that discussion. But I may be misremembering.
Yeah, so looking at the numbers here and having recently read, having the discussion in CFRG about the rekeying stuff, I read the paper that was cited there, which I hadn't read before, another paper on the same topic, and the numbers that we've chosen are, if you have full-size records, pretty much exactly what that paper recommends for rekeying for maximum lifetime of the keys. So that kind of supports the numbers that we have. I mean, we'd be off by 0.5.
Which way?
We're going too far.
Okay.
If that's the case, but we're rekeying slightly later than we need if we have full-size records all the time, but probably rekeying earlier than we need if we don't. That was the conclusion. And again, that was just for the optimal key lifetime if you wanted to go all the way out to some stupid number of blocks. I don't know. It was 2 to the 84.
This is Mizir.
This is the Adabi Bolair paper.
Yeah.
So with a block size of 2 to the 128, it's 2/3 of that space that you could actually 2 to the 2/3 of 128 that you could get to if you follow the optimum rekeying schedule that they recommend.
With linear keys, linear key schedule.
Yeah,
because I haven't read it yet.
The properties are basically the same with parallel and serial, according to the paper. So,
do they have a particular tolerance that they're shooting for? Is it?
I don't know what they were shooting for. I didn't read it in enough detail to be able to speak to that. But I mean, we've picked something. Sure, we can bike shed on that. Maybe the correct thing to do is ask for a pull request with justification associated with it at this point.
So I spent a little bit of time to break down the issue, which is clearly easier for people to understand. So basically, it doesn't depend on the record size. It all depends on the total length of the messages in the section you have. It doesn't depend on your record size at all. It's not matter what is the record size. It's the matter is how large is the total data you have for the section you run. So the record size, the max or the mean is not really matter in this limit and in this context in TOS.
So is your proposal that we merely tell the that we keep the same safety margin but tell implementations to count bytes rather than records?
Oh, I would urge everyone to consider to use the margin only like 1/2 to the 32. And just put a limit on the total data. And we does not need to care about the record size. Record size, small or large, it's not really matter. The matter is the total data in the section under a given key.
Well, I thought for the authenticity limits there was a matter of how many authentication tags you processed.
But the thing is, even with the limit, with that things, it's safe way enough from to worry about either the key or the IVs to be repeated. So it's way below on the margin side. But even let's say one block normally you do one of them. So for one block, right? And you run up to 2 to the 64 IV, for example. And in that way, because you still your chances for IV to repeat is no, it's not going to repeat at the same time, so it does not matter.
Don't remember that being the analysis in the
it's
paper.
Yeah, even in integrity, it's not matter. The matter is the total data in that section under a given key.
Well, I guess so. As I said, I defer to the chairs how to proceed, but we had, like When I have the chair of the CFRG strongly disagreeing with this position, I'd like at least I certainly can't really see how we can make a decision here unless more people are rising to this position.
So I think the quickest thing, Quinn, is to put in a PR, and then we can turn up the cryptographers who are qualified to argue this point, because I'm not in that group. So we can get Kenny and company, and you guys can like battle it out.
I could do that.
Yeah. So if you send a PR, that makes it much easier, because we know exactly what text you want to change it from and to, and I don't know. Then all the other guys lining up behind you can tell you what the answer is, because I don't know.
Yeah, because the last discussion we had about the authentication was the data limits, regarding to single key or multiple keys. But in the multiple keys, basically you multiply the data complexity. So if you look at about the data complexity as a whole, either data or how many queries you have, and the total would be in about that I'm talking about here is in the one given key with that data limit.
Okay.
But if you care about everybody using GCM at all, and then it's different scenario.
But that's precisely where we got this limit from, right? We got the part of this limit is in fact derived from the overall safety margin. Anyway.
No, but the thing is, if you care about multiple keys, then you combine all the data, total data for all those sections. If they are under that limit, then you're safe.
So I think the best thing, Quinn, is to submit a PR, and then we can.
Yeah, I could do that.
Yeah,
great.
please do that, because
Yeah.
let's have the mic, other people go to the mic, and because I think we can't get to a complete resolution here now. So,
Yeah, sure, I do that.
yeah, thanks.
I just wanted to offer to review.
Okay.
Excellent.
Thanks, David.
David McGrew put his name in the ring to
Do you
review.
know anything about GCM?
For which we're all
Yeah.
grateful. A few things. Martin Thompson, just to correct Quinn, it's not the number of bytes that you send, it's the number of blocks that you encrypt, which makes it more complex to track. Yeah, see, we don't track that number. As a practice, the number that we're actually tracking is the record sequence number, and that's the easiest thing to work on. And if you're asking people to track something else, then they're far more likely to get it wrong. That's my argument. Yes, it is easy to do these things in theory.
Number of records, then I have to calculate what is the record size. So I have to value.
Will you go to the mic?
Okay. Thanks.
Stanisław Myśler, CryptoPro. I've made a talk about Rekin yesterday, so just a little comment. Of course, these numbers are quite conservative, but we should have some extra level of security, I think, is this level in this case, and not because of some properties of GCM mode, but because of some properties of the final hardware, software that we can't know now. And if it's quite okay for the performance, for the implementations, this extra level would be okay and it will be needed. And about the mechanism of Rekin, it's very good. I told yesterday that it's the same one that was very thoroughly analyzed by Belar and Edele, and I think if we start our work in CFRG about our document on Rekin, we'll definitely fix this mechanism as one of good ones. And so I am for the leaving things as they are. The values are seeming quite good for the reasonable level of security, reasonable performance. So I think this question can be discussed later. Maybe in CFRG, but I think we wouldn't have a common solution, common agreement. Every cryptographer will have each own opinion, but I think no one would say that this level of security is not enough now. So,
Thank you. One more slide. Okay. Right. So now we're up to the timeline. So we're, as I said earlier, the working class call ends on the 20th. Please do, in fact, get me any comments you have by the 20th. I can issue a draft 19 with the changes we made here, described here, modulo, as I said, the record sequence number 1, which will defer, by the 1st, and shortly thereafter, I would anticipate that we'll that NSS and Boarding SSL and company will upgrade to draft 19, since it's like not going to be a very big change. I will commit to make a serious attempt to get the record header data done by the end of the year. and then we can have a discussion for a couple weeks, and then, you know, I've got a PR for draft 20 for that last change if we need to make it. So it's just like, I'll just land it. I guess you were saying the end of January for the cryptographic review period.
Yeah.
You know, I'm leaving a week and a half on the principle that almost no changes will be needed. If something catastrophic is found, obviously need more time. I mean, I'm sure we'll find some stuff. You know, that, you know, people will say you should explain this more clearly or whatever. In particular, I know that the sections of security analysis could use a little buff up. So I imagine someone will catch that during review. Unless something major is found by the 31st, I should be able to get a draft 20 that's public accessible by the 10th. I'm now done. Unless someone
Just to check here, how many people have read draft 18? Raise your hand. All right, super. Let's get those comments in.
Yeah. So one more question, Ecker. I guess there was a message that I sent that was listed linked to a blog post, and they said it would be great if you had a state machine. Are you planning?
Yes, I'm planning to add a state machine in 19.
Okay, great.
I'm trying to figure out the best way to do that is in a way that is clear. I find these like these box diagrams, these like box diagrams with arrows and stuff, like get impenetrable about a state and a half. But I will do something or other. And I've gone through the comments they made, and the best as I can tell, they're either things we know or the things we are already aware of, or their difference of opinion about how we ought to proceed, or they're based on misunderstandings of the specification. But if somebody believes I'm wrong, you know, please do shout, and I will attempt to fix them.
And for everyone else, please don't do that again. The blog post link thing I didn't like, so I kind of smacked them around a little bit.
Okay. I mean, certainly if they post their comments directly to the list,
Yeah,
I mean, Laurie posted quite a long response. So, all right, I'm gonna sit down.
All right, so we had 95 minutes scheduled and we took 35. So we got a whole bunch of time back. So that means we're going to start doing some agenda shaking. So do you want to do this or do you want me to do it?
Yeah. So here's a fun topic. TLS version numbering.
You want to stand up there and do the whole thing?
This.
No, so we decided this is TLS 1.3 related. So we figured we just like add this in and save Ecker some time. So we do this.
No. So now you know how we feel. Okay. So we've had some discussion on the list as to what the name should really be, let the real TLS stand forward. And I guess we've had a couple options. Okay, we've had a couple options. And well, we've started with TLS 1.3. Some people have suggested TLS 2 or 2.0, but that might be confusing. And we have TLS 4 or perhaps more, depending on what you like to maybe avoid some of the confusion with SSL 2 and SSL 3. TLS 98, yes, very good. So these are kind of the options we've heard.
I mean, so the question really is like, are there any other options that anyone wants to throw up on the floor now? I mean,
I bet 1.65 is a compromise between 1, 3, and 2.
all right, buy that meta beer later. So you all have grasped the seriousness of this point. So I think the people that have made these requests are kind of understand it as well. So but we do need to actually knock this out. So our plan basically is.
So we can, yeah. So yes, if you understand what we're talking about, then please hum for one and only one of these choices. So we'll have 4 choices, and they're going to be leave it, TLS 2.0, TLS 2, or TLS 4. And you can hum for the dog. What's the name of the dog?
I don't know. So does everyone understand the questions, and would anyone like to bash the questions? Because this is always the fun part. When we put up questions, everyone wants to tell us the comma's in the wrong place.
Or any other comments?
So
Some people had said TLS/2, and I've also heard TLS7. Because it's the 7th version.
TLS/2 and TLS2 are the same thing. T2.
T2. All right. Going once. Here we go. Up. Do we have somebody else who? Okay. How many people, if you want to leave the name as it is, TLS 1.3, please hum now. All right. If you would like to rebrand it to TLS 2.0, hum now. If you would like to rebrand to TLS 2, please hum now. Okay, now for the last one, rebrand to TLS 4.
And no, one on Jabber for 2.0.
One on Jabber. Okay, I think still, according to my ears, TLS 1.3 stays the same.
We still need to confirm this on the
Yes,
list,
this will
but
still
there'll
be
have to
confirmed
be
on the
a
list.
avalanche of support for it to change.
Oh, I'm sorry. I apologize. I forgot one issue. No, it's I don't. We got. Can you pull up the GitHub? We're staying with 1.3, I think.
We're staying with 1.3. Well, we're going to take it to the list, but the consensus of the room is on 1.3.
Yeah. Issues. Blah. Are you going to have the homepage done by the time it's ready? Not the draft. Yeah, issues, good. Pull request, sorry, my mistake. So Matt Green proposed a PR to require point validation for EC points. And I just wanted to see if anybody has any objection to that.
So I thought that when we did 77, whatever it was for 25519, we had a bunch of discussion about this doing the point verification stuff, and we put it in, we took it out, and at the last minute, like the cryptographers freaked out. So I just want to make sure whatever we do, we're not upsetting that.
Right. So right now there's a requirement for validating group elements for finite field Diffie-Hellman, but not for validating group elements for elliptic curve Diffie-Hellman on either the NIST curves or the CFRG curves. Yeah, so I guess I was planning to merge this, but like I want to see if anybody objects.
Isn't there a bunch of messy IPR that would prevent us from doing this?
David might know.
I mean, isn't it like BlackBerry suing people?
I do not know. I knew there.
There's other. Yeah.
Is I guess here's a question that I think David can answer. Is point validation in fundamental algorithms? No. Okay.
Yeah.
That's for both the NIST curves and the X25 and 448.
So my memory, again, I'm really out of my depth here, but my memory was that on the CFRG curves, at least, the effect of bogus points was limited to allowing you to force you into one of a small number of values that had non-contributed behavior. But I could easily be wrong about that. And this curve is different.
So practically, this is Nick Sullivan. Practically speaking, on a lot of NIST curves, point validation is implicit because of the conversion to Weierstrass form. So validation does happen in most applications, even if it's not explicit.
Kyle Neckrits, I think like regardless of what it is, we should be explicit about whether like what is necessary, what isn't necessary, and get everyone, the cryptographers, to sign off on that. So it's very clear what needs to be done.
So perhaps we can bounce this question to CFRG for opinions.
I'm not sure about what the concern about IPR is, but at least ICVERN2 had mandatory recipient tests for several years. It's in the IANA registry, and nobody's yelled so far.
Okay. This will of course become extremely relevant when we examine the draft green something or other in a few minutes. Okay. So I guess I'll fire off email to CFRG to ask for an opinion on this topic. Oh, you're on.
You're on, Chef. Actually, the recipient tests in ICE also apply to finite field DH. When public keys are being reused, as in Matthew Green's new draft.
Correct.
So.
Yeah. So I mean, so as I understand it, so we do have defined tests for the development in TLS 1.3 now, though it's limited to I guess this between the values are just like they're just within the range of the curve of the group. Okay.
All right, so now we're up for, that's not the slide, TLS visibility inside the data center. So two things, not brand new people in the IETF, but first time presenting here, so everybody be nice. Everybody else that's gonna get up has been around for a long time. So without further ado, I'll let you guys, they're going to run the slides, and I guess we're going to try to hold comments till the end, or questions till the end, so they can get through the slides, and I'll let them do the microphone thing. There is the pink box that they want you to stay in. It's kind of small in this room. It's for the remote people, so like the camera over there. So if you're in, don't move too far. It'll be better for people that are remote. So thanks.
Very good. So
one more thing. I am going to run a timer, but since we have more time, we're going to play it by ear, but I'm going to start it for 20 minutes. So when it beeps, you'll know what's going on, but I'm not saying stop. Yeah.
All right. Well, thanks very much, everyone. Jason Whitty, I'm the Chief Information Security Officer for U.S. Bank. I'm also representing the Financial Services Information Sharing and Analysis Center. That's about 6,600 financial institutions all around the world. Don't let any of that scare you. I actually have an engineering background, and I do still get my hands dirty. So if you like what I have to say today, I also wanted you to be aware I'm working on my 3rd degree Hapkido Korean martial art black belt. And if you like what I have to say, that's awesome. And if you don't, choose your words a little more carefully than normal, I'd probably say. Now, I really appreciate the ability to address you here today, and IETF members, but certainly the first time we're presenting here, and really have a couple of things that we're trying to do. The first and foremost is we're trying to make sure that TLS 1.3 gets adopted in the most wide scale possible. We are very much privacy advocates, very much on the sort of same bandwagon everybody else is, trying to make sure that there isn't unauthorized tapping of the networks and nobody basically noticing this has been going on for a long time. That being said, we've got some real practical enterprise use cases that we want to present today. And we also didn't think it would be very fair if we came to the stage for the first time and basically said, hey, hey, we're kind of raising a little bit of a red flag here kind of late in the game, without having some sort of solution that people could poke holes in as well. So there is an internet draft that you'll see towards the end. We're really not here to go through the internet draft in sort of full detail. It's kind of half-baked right now. It needs a lot more socialization, but we wanted to have this conversation first and just kind of present to you why we really care that much. So Steve Finter is with me. Steve is kind of jokingly at US Bank kind of considered the, oh my God, what in the heck is going on with this application? Nobody can figure it out. Go call Steve. That's basically Steve. So I don't actually know his real title, but that's his sort of functional title. So that works really well for us, and he'll walk through an example, and then I'll give a couple of information security examples as well. So with that, I'll turn it over to Steve.
Yeah, maybe many of you assume this, but we were part of the coalition that put the BITS email together on the email list, and we followed that whole 100 email chain. So for those that participated, this is kind of an extension of that discussion. And I'd like to, what I'd like to do for 5 or 10 minutes is to try to illustrate the need for out-of-band decryption inside the data center in ways that we can't really do over an email list. And by the way, a lot of the topics that I'm going to discuss today are part of the effective ubiquitous encryption draft that will be discussed in SAG on Thursday. Section 4 is enterprise. Can we do the next slide? So what I put up here is kind of purposely hard to read. But I'm an enterprise troubleshooter, which means I'm a sniffer guy, translated. And this is an internet-facing application. And what I did was I included all the infrastructure just so you get a view of what the environment is really like inside an enterprise. So just to try to explain this real briefly, the upper left is where an internet user would come in the internet. You'd hit the firewall, you hit a load balancer in the DMZ. You'd head into the middle column, which is all the main processing. It's web servers, app servers, middleware, down to the mainframe on the bottom. On the left side is database calls and authentication calls. On the right side is fraud monitoring. And the upper right is service calls going out the internet. So you hit the internet proxy, you go through firewalls, and you're out the internet. And when somebody logs in to this particular application, they hit this entire page, literally. And if something breaks, any one of these 400 boxes could be the cause of the problem. So it could be a Cisco problem, the ARP table could be messed up, there could be an interface card that's gone bad, there could be a firewall that's gotten overloaded, it could be a software bug. Literally, it could be anything on this page that's the problem. And I frequently get incident calls with 30 people on the bridge. The application support guys are on there. The firewall guys are on there. The network support guys are on there. The mainframe guys are on there. The server guys are on there. And all of them say the same thing. We've looked at our logs. We don't see anything. CPU's okay. Memory's okay. We don't know where the problem is. Now, not in those exact words, but that's essentially what happens. So they come to our team as a last resort to tell them where in this picture the problem is. So in today's environment, by the way, this is TLS almost all the way through this picture, which is why TLS is a concern for us. So in today's environment with TLS 1.2 and static RSA key exchanges, we're able to put a sniffer anywhere in this picture, above and below the firewall, above and below the load balancer, above and below the web server, whatever. And if we can find the transaction that's failing, we can identify where in this picture the problem is and get everybody unstuck. But the only way we can find a transaction is to be able to decrypt packets and look at layer 5, 6, and 7 to figure out where it is. So right, a user with an intermittent problem, when they call in, we're going to get a user ID, an IP address, and a timestamp. And we're going to find out a particular screen that they were on that's failing. And we have to go find that post and that URL in the sniffer trace in all these various locations. And again, you can't see that in an encrypted packet. And I'll try to illustrate that a little more. Let's go to the next slide. Oh, actually, one more quick thing on that one. This note on the right side, our particular company has 1,500 total applications, unique and different. So if you take this picture, maybe 2/3 of it is shared infrastructure, maybe 1/3 of it is unique. So take 1/3 of this picture, multiply it by 1,500, and that's the complexity of the environment that we're dealing with. So today I may deal with this application, tomorrow it may be a different one, and I need visibility in a different place. Okay, next slide. So I did a log on to one of these applications, and this is a sniffer on our internet connection. I picked a minute before and a minute after my login time, and I mined out, well, another problem is I used to be able to just mine out the user's IP address, but now that we have content delivery networks, that address is obfuscated and we get a CDN IP address. So I have no idea which IP is me. So I have to mine out everything in and out of this particular application. So in the red circle there, it's 3.6 million packets that I have to go through and figure out which session is mine. Okay, next. So this is a view of those internet packets. I've changed the IP addresses, but none of those IPs are mine. Those are all content delivery network IP addresses. The ports are changed. you can see the encrypted packet at the bottom, and or one encrypted packet at the bottom. So there's literally nothing in this packet or any of these packets that will tell me this is my session. It's like looking for a needle in a haystack, except that there's no needle. It's just a haystack with no clue of which person is me if I can't decrypt packets. So next slide. So now I've decrypted a set of packets. This is me. It's a dynamic IP address, so it's not a super big deal. But now it's like light bulbs come on, and the IP address there is me. It's my mobile phone IP. And now I know which TCP conversation is the right one, so I can do a TCP conversation filter, and I've got something to analyze. But my job isn't over, because with a content delivery network, I'm actually coming from 5 different IP addresses in the delivery network, not just one. So now that I've found this and I found true client IP that tells me which IP is mine, I have to go look for other sessions that use that same IP address. And true client IP is not in every packet or every connection. So I have to start looking for other things like user IDs and that sort of thing to find all the TCP conversations that I need just to analyze the particular login that I did. So I spent 2 hours a couple weekends ago just finding everything that was my particular login on the internet. And I guess I'll throw in a general comment for the folks that are working on things like TCP session multiplexing. It does a lot of good things for performance, but it's terrible for support. Because a job that used to take me 2 minutes, literally, to mine out my IP address, get 2,000-3,000 packets and start analyzing, now it's 2 hours of work sorting through all these different TCP conversations, different IPs, different port pairs to try to find the information I need. Okay, next slide. I also, but before I get to this example, let me just mention a couple more general things. But this is a huge point, which is the problem I just demonstrated up there. We have through the entire data center, through that 400 box picture, because IPs are NATed all the way through an enterprise. Web servers NAT, load balancers NAT, firewalls NAT. And when I go to take a trace, I can't find my packets if they're encrypted. I have to be able to decrypt them and find the true client IP if it's in there or X-forwarded for. I have to look for the correct post to identify the transaction I'm looking for. Another example I want to give you just to kind of illustrate what it's like troubleshooting when you can't decrypt. There are applications that send a particular request and they put an identifier down in the layer 7 payload of the packet, not the HTTP header, but the layer 7 payload. And it's an ID that identifies that request. It goes through multiple layers of infrastructure, firewalls and routers and whatever. It gets to the far side. The far side answers sometimes from a completely different IP address, and they put that same identifier down in the layer 7 payload of the packet. So if this is encrypted, there's absolutely no way to find those partners, the request and the response, if you can't see that identifier in layer 7 of the packet. So I've worked on problems where the one side says, hey, I sent a request and you didn't answer. The other side says, I got the request and I answered, and there's 20 pieces of infrastructure in between. How are you going to find out which piece of infrastructure is the problem? You have to decrypt those traces, find the identifier to find the right packet, and then follow it through your network, taking traces and decrypting at each point to isolate it to the firewall that dropped it or the switch that dropped it or whatever piece it is. So I'm going to close my part with a little troubleshooting example, just again to try to illustrate what I'm saying. And again, the point here is the need for out-of-band decryption. And maybe I need to say another point here, which is, I've had suggestions from people like just do man in the middle. Well, in that first diagram with the 400 boxes, I would need 100 man in the middle points in order to get the visibility I need to isolate these problems. So man in the middle is not a solution. I've heard troubleshooting at the endpoint. And I'm going to actually show you an example of endpoint troubleshooting in a second. So this is a login to an internet banking application, and we had this weird problem where half of the screen would not populate. And there's supposed to be a password box under the piano keys with the word password, and it wasn't showing up, so the user could not log in. Now, fortunately, it was a small percentage of our user base, but this could have become a huge severity 1 killer problem if we didn't get it figured out. Okay, next. So this is kind of a remake of the application log. I changed a couple things, but it's essentially what was there. And the application guys came to me and said, this is what's in the log, and this is all there is. This is all we have to go on. So if you look at the upper right, you can see this repeating pattern where the guy enters his user ID, and then to the right, he gets a challenge question like, what's your mother's maiden name? He answers the challenge question, and he gets a response that says the answer's okay. And then something somewhere goes wrong that we don't know about. And then 5 minutes go by, and the same thing repeats over and over. So if this log was all we had to go on, right, if we couldn't take a trace and decrypt it, then based on this log, where is the problem, what is the root cause, and how do you fix it? Right, that's the dilemma that we have. And I'm thinking that you and I could look at this log all day and not come up with the root cause of this problem. Right? This is one of the problems with endpoint troubleshooting, that logs tell you so much, but they don't always tell you the root problem. And when the logs don't tell you enough, then you're stuck unless you have some other method of getting more information to go on. Okay, next. So I was able to trace the back-end exchange that I just showed you, the challenge question and all that, but only by decrypting packets, because I had to, because you don't know which app server the guy's going to hit. You don't know which authentication server the guy's going to hit. The IPs are all changed, so you have to take a trace and decrypt it. And by doing that, I was able to verify that that exchange did happen successfully, and the last answer made it all the way back to the app server. So the authentication part was okay. And then I went and I took a trace of the actual screen going out, the faulty screen. This is on the internet taps, and this is the right screen. I know that from the analysis that I did. So based on the information in this encrypted packet, we have the same 3 questions. Where is the problem? What is the root cause? And how do you fix it? And I'll suggest again that you and I could sit here all day looking at this packet, and we would not come to the root cause. Okay, next. So now I've decrypted the packet, and light bulbs start to come on. And you can see the word password on the right there. It's highlighted. That's actually the password box that was missing. So I know now that that password box got sent out with the screen and went out the internet to the end user. And the TCP layer told me that it was ACT, so it actually made it all the way to the end station. So something went wrong on the PC. So we might just assume that it's a PC problem, but we're going to go one step deeper. So if you look at the hex data of the decrypted packet, you can see the verbiage up on the upper right is the text on the screen, and restart your login was the last thing that printed out. And then after that, there's a long string of zeros, which looked funny to me. And it's in fact not supposed to be there. So I went to that. And by the way, this problem went on for 2 months. And the app guys, with only the log to go on, all they can really do is blindly read code. And that's a very slow, painful way to try to figure out a problem. So in 2 months' time, they hadn't figured it out. But I gave them this information, and within a day, they found a bug in the code. It had been there for years, and something changed at the PC level that made it come back, and the problem was fixed. I'm going to turn it back to Jason.
And for those of you that are decoding the hex that was on that screen, this user did actually change their password, so I just want to point that out as well. So you thought I missed that. All right. No, so the same practical example also exists in fraud monitoring as well as network security monitoring in general. So the same ability, again, if you take this type of an infrastructure and we've got roughly 400 boxes on the screen, and then you multiply, a third of that or a quarter of that by 1,200 applications, right? if we were to try to implement something that is going to do fraud monitoring for transaction related fraud, or we're doing security monitoring for things like data loss prevention or malware prevention or any of those traditional class of information security controls, we simply cannot scale. If you're going to try and get to every single box on the network, you've got multiple vendors involved, you've got multiple boxes involved, you've got asset management problems like you wouldn't believe. And the other thing that I'll just say about this is you should be thinking at this point that US Bank is kind of the people up here talking about this problem sort of publicly, because we're kind of one of the only ones that were sort of able to do that for some reason. But this is not an isolated problem. We're aware of a lot of other companies that have this exact same problem. I'm personally aware of 27 of them. I know that's more than that. But the point is, you'll see these aggregation points that we have on there very deliberately, where within the network, so this is not the internet side, right? What we are advocating for as part of this conversation is anything sort of from the top up is TLS 1.3 and absolutely no other sort of optional extensions or anything else. But below, within the data center, where it's our data and we're trying to protect it from being stolen or hacked or copied or illicitly moved or whatever it is, that we've got some visibility that those types of actions are happening. And so we've got data loss prevention monitoring that's aggregating and decrypting in certain places. We've got fraud monitoring that's looking at the transactions that are coming in from multiple applications, scoring those for fraud, et cetera. If you go to the next slide. So again, we are aware of financial services companies that have this issue. By the way, a lot of their PR teams basically came down and said, we don't want you getting in the middle of this privacy versus security thing. And I don't actually see this as a privacy versus security thing. I see this as something where there needs to be sort of a blend of, there's practical implications of TLS 1.3 in the enterprise. And what we're trying to do is actually protect personal information from being stolen in the first place. So it's actually an issue from my perspective where what's really, really good for the encryption channel, you're protecting the channel really well, is actually creating a much bigger problem for the visibility that something bad is happening over that channel, like, for example, data being stolen and exfiltrated from the network. So it's that type of thing that we're trying to balance and really looking for a solution around. We're definitely not asking for RSA to be put back into the algorithm. That was a sort of early on misconception. That's not what we were trying to do here. All we were trying to do is saying, look, the regulators take these standards, whether you're applying them to an intranet or the internet as a whole, and they kind of force it down, a myriad of different companies around the world. So whatever we do here is going to have a much bigger impact than might have originally been anticipated. It's not just the internet as a whole or the public internet. It's going to affect large-scale enterprises as well. So if you go to the next slide, what we really are trying to do is say there needs to be some sort of solution within the data center, and we didn't want to come to this group without some sort of proposal. What we've basically done is Matt Green worked with us to draft an internet draft that's out there. You've seen that. It's posted. There's no intellectual property issues with this particular draft, but the big point of it is it's half-baked. It needs a lot more discussion. It's not suitable for publication today. It won't be tomorrow. It needs a lot more smart people looking at it, and smarter people than we are. But if we do nothing, what this is going to mean is one of three outcomes. Either those large-scale enterprises that fall into the category that we do are going to stop encrypting their internal traffic and just do everything decrypted. So just clear text, which, by the way, a lot of companies just operate in that manner today. So it's not a problem for them because they don't encrypt a lot of their internal traffic. Financial services companies have pretty ubiquitous internal encryption practices, so that's why it's such a big deal to us. But there are a lot of large-scale companies that also have ubiquitous encryption internally for transport layer encryption in general. So you'll see that either it's going to go back the other way and you're going to pick a lesser thing to deal with, lesser problem to deal with, or pick TLS 1.2 and just stay on that forever, which I think if you go out 10 years, that's going to be kind of a pain for everybody in this room. If, half of the industry is kind of on TLS 1.3 and the other half's on 2, I don't know how big of a deal that is for you, but that is a potential outcome. The third outcome is simply that we come up with some sort of middle ground, and there is an optional extension for enterprises within their own four walls, within their own data centers that control their own data and are trying to protect that data from theft and fraud and other types of use cases. That's really what we're trying to achieve, is some sort of happy middle ground. So I know that's a little bit controversial. If you go to the next slide, we are sort of on the fence, to be honest with you. Looking at the specification that's out there right now, the drafts for 1.3, it looks like if we were to have some sort of solution for a static Diffie-Hellman exchange, that could potentially not be violating any of the things that are in the current draft. We certainly want to socialize that more. Very much open for your input on how that would best work, if it would best work. If it's completely ridiculous that we're even suggesting that sort of thing, we do expect there's going to be a pretty lively discussion on that. But that's why we're here, and we're not trying to do anything outside of transparency. We're literally just trying to protect our networks and make sure that we've got the visibility we need to both keep them running from his side and keep them secure from my side.
And now the queue forms. We'll do flow control just so, because people tend to line up at the mic whenever they want. So.
Hi, Yovnir. And you mentioned at the start that your goal is to have TLS 1.3 used in your enterprise and everywhere. For me, that is not a goal. And TLS 1.3 brings a few new things like zero RTT, which I don't care about, and PFS everywhere, which I do care about.
Sure.
And that's the part I care about. If you remove the PFS, I don't care about TLS 1.3. 1.2 works very well as it is. And
actually, let me push on that though a little bit. So do you not care because this particular body can maintain both of those standards for the foreseeable future? Is that
this body doesn't need to maintain 1.2. 1.2 exists. It's in code bases everywhere. It just works. And the same could be said for 1.1, 1.0, but we have specific things that we know are wrong with 1.1 and 1.0. So we don't want to go back to them. 1.2 is one. Yeah. If you don't want PFS, 1.2 is fine.
Yeah, a quick comment or question. I thought I've heard people in this room say that when vulnerabilities are found in 1.2 that they're not going to be fixed. So I didn't have the impression that 1.2 was a viable long-term standard. With all the right, we have multiple vendors in the data center. They all have to agree to keep it going.
There's nothing promising us that any vulnerability found in 1.2 won't apply just as much to 1.3 and force us to create a 1.4 that doesn't have that vulnerability. So 1.3 is no insurance against that.
Yeah, but again, if you did that and then you didn't have the PFS limitations.
So, the same point is that what is suggested in that draft is really something that the server can do on its own. I mean, the client can probably tell that it's happening because the server will have the same
client would
the same key share all the time. But unless the client is specifically looking for that, the client would just work.
Right.
So I'm not really sure why you need a draft for to kind of standardize it or make it look more secure than it is. And yeah, it's been sent to the mailing list. You can make the Diffie-Hellman key share static, and then you lose PFS, but all the other things still work. So
yep.
I'm not really sure why we needed a special draft for that.
Yeah, and the intention from us is just to make sure that we've got a common spec that all of the vendors are going after, and we push for that within the internal networks.
Back mic.
David Summers Harris from Rockton. I'm not a protocol guy, I'm an operations guy, but so I don't have much to speaking to the protocol side, but you said you've got three options, basically use 1.2 forever, stop encrypting, or in order to use 1.3, need to tweak it. But actually, I think option 3 is possible without tweaking it. Just as a suggestion, you mentioned that you're using a CDN, so terminate it, and then, audit it, process it, whatever you need to do troubleshooting, and then re-encrypt it, which is what you're already doing. So
that was the man in the middle comment that he made before. And again, if you look at that big block diagram, right, the 400 boxes, we'd have to have all of those different, because all of those things are communicating with each other over TLS as well,
right,
internally. So that's the challenge that a lot of large scale enterprises have is it's all that internal sort of east-west traffic.
Okay, so it doesn't cover like 100% of your problems.
Correct.
I would, from my experience, say it probably cover like 90% of your problems.
And I would say it covers about 10.
Oh, really?
Yeah.
Okay.
It is a very valid architecture, and there's certainly things that we use that architecture for. I mean, user proxies, right? It's a great example. Somebody's trying to steal, personal data, and they're trying to email it out through, something. We're going to catch that through a proxy type solution or through a routed solution over an email gateway, right? But we're not going to necessarily be able to do that at that scale on the screen.
Okay, thanks.
Thank you for that, though.
It's DKG and then Ecker. I don't know if you're in line, and then Lee, and then.
Hi, Daniel Kahn Gilmore with the ACLU. So thanks for presenting this, and I appreciate the difficulties of maintaining large environments. Can you go back to the back a slide or two? Yeah, that one there. So you've got this boundary here, and your proposal is, I guess that top one is TLS 1.3 without static DH, right?
Correct.
And then below it, so you've already
The
got
top is ephemeral and bottom is.
So this is already a man-in-the-middle scenario, right? You've got a boundary, and you're terminating the TLS at the top using one mechanism, and then the TLS is, you got other forms of TLS happening in here, right? So you have some visibility already, at the very least, along that boundary.
Correct.
Right?
Full network egress.
And the argument that I heard you saying about why you don't use debugging at the endpoints was because the endpoint logs are insufficient. Is that right?
Generally speaking.
So,
and you may not know which endpoint is causing the problem in a scale that's that large.
But okay, so my understanding is that for debugging purposes, you guys keep logs of all of your internal encrypted traffic. Is that right?
Not necessarily. There is some forensic recording.
Okay, but you're logging all of this traffic so that you can decrypt it later should you need to. So you have somewhere a large corpus of all of your customers' data that's flowing over the network. And somewhere you also can get access to the secret keys that are floating around in here so that you can decrypt that entire corpus. So you're sitting on top of a major, I don't know what to call it. It's an attractive nuisance.
Sure.
Yeah?
Attractive nuisance is a good vernacular for that.
Sorry, yeah.
Right. And there's a lot of key exchange processes to
right.
get access to that, and
so
God has to sign off.
So you're comfortable with this attractive nuisance. That's the only way that you see to get to this particular process here. But you're concerned that regulators are going to come along and say you have to use TLS 1.3. And one of the possible responses to that is we're just going to use clear text traffic. The regulators won't care if we do that. Is that
I'm
right?
not saying that's going to apply at all for financial services. Not at all. I'm
Okay.
saying companies in general, right? We would never take that approach. We would take the approach of saying we'll stay on TLS 1.2 forever.
So, okay, I mean, I disagree with Yoav as far as whether staying on 1.2 forever is a good idea. There's a lot of additional things beyond just the PFS, like there's more of the handshake that's encrypted. So I hope that you will not stay on TLS 1.2.
We prefer not to.
Great. This approach loses the forward secrecy, which is a major flaw, and I recommend that you don't do that. If your problem is that you don't get access to the data because the logs that are being provided are insufficient, you can add one thing to the log, which is I will remember the ephemeral key for this particular session alongside all of the other transactions in the log. And then when you want to decrypt trace X, you find the trace that matches it in your logs, and then you can decrypt it using that ephemeral key. So there's additional ways to do this without blowing the forward secrecy issue, right? I mean, yes, now you're storing the keys. That's the same attractive nuisance that you have right now. I would prefer that you just not open yourselves to that particular vulnerability and that you log the things that you know you need for debugging in the future. I think this whole construct is not something I would want to see in the base spec. I do not want to encourage people to do this, and I do not want to give them a pass by saying, oh, well, it's in the base spec, so that's okay. If we go forward with a draft like this, I'm going to encourage that this draft actually be a draft that says, use ephemeral Diffie-Hellman. And then with some caveats at the bottom say, here are all of the problems if you don't use ephemeral Diffie-Hellman. And then if you want to adopt that approach, fine, but we're not giving you guarantees at the end.
Yeah. No, I think that's something that's very valid, and we should definitely look into that. Sure.
I know exporting ephemeral keys has been discussed by a few people. The one question I have about it is, to use the troubleshooting example, when you're tracing something, you don't know which app server they're going to hit, and you don't know which TCP conversation it is. So you trace everything for 2, 3, 4 minutes, you decrypt it all, and then you go look for the post or whatever it is you're looking for. So that's a lot of ephemeral keys from a lot of servers, because the problem may be in the web server, it may be in the app server, it may be in middleware. So it's not just one ephemeral key in one session. It's tons of ephemeral keys over tons of servers. So it has to be debated if there's a practical way to make that work, to export all those keys, put them somewhere, index them, keep track of them. So I'm personally not opposed to that solution. It's something I think this group could hash out. I've heard other people say the static ID is better just because of simplicity, and but it's a valid solution, but it has some challenges that I think need to be hashed out.
Lee Howard. A little off topic, but I've got to say what I always say. You did complain that you got NAT throughout the network, and that makes things a little more complicated. We have a solution for that. You could do IPv6, make your life easier.
We'll eventually get there. Thanks for
I was waiting
that
to see where he
plug.
was going to go. Nalini, you're after Eric, and then guy in the
Yeah,
red.
just a quick comment on that. NATing is done for reasons other than IP address exhaustion. It's done for multipath routing within a data center so that return packets find their way back to the same guy that sent them.
Yeah,
Lee was joking.
he's not totally serious.
But we will get to IPv6.
Sorry.
NV7, whenever that comes out.
Sorry.
Okay, Rich Sauls, Akamai. I worked at IBM for 5 years, so this is actually a pretty simple diagram compared to what I've seen in many enterprises, former customers. So you can, if I understand correctly, you can get what you need without any protocol changes just by keeping the EDH for a week. Right? Yeah, yes, it means a static key, non-ephemeral. Yeah.
Static key solution would meet our needs.
This okay, so
Sorry,
yeah,
the static key solution would.
the static key. Okay, so if what we,
Or long
I mean, I
lived.
read through Matt Green's document, and actually, what I mentioned earlier, but I would propose more than semi-seriously, is we take out his security considerations and just put them into the security considerations of the TLS 1.3 spec. What used to happen back in the prohibition days is you get a can of grape juice and it would say, don't do this because it could become wine. And so it's like, don't do this. And if people like you have needs to do it, fine. But there's no protocol changes needed. You can't, as Yov pointed out, you can't stop a server from behaving badly. For all I know, there's some ASR 33 in the back room, recording my bank ID and password. There's concerns about informed clients, and maybe you can just do that, put it on your webpage. This is no PFS, but yeah, I don't see it as a big deal.
Eric Scrolla. So I guess maybe a few pieces. So to the best of my knowledge, the specification does not require generating a fresh ephemeral diffie-Hellman for every connection. Someone mentioned to me that thought it did. I went and looked. I don't see where we mandated that. In fact, the security considerations, I think, pretty clearly suggest that you might not do that by saying, if you don't do this, this is what happens. I know that there's at least one class of servers which already used which don't exfiltrate the diffie-Hellman key, but do use the same diffie-Hellman key for multiple connections for elliptic-curve diffie-Hellman. That's what NSS does by default. So it's not like there aren't servers that already do this. It's a little unfortunate that we don't have any security analysis for this mode. So I guess. Speaking informally, my impression is that people generally think that this mode is sound, but that we don't have a security analysis for it. And if you go and look at the papers that have been done analyzing 1.3, they generally assume that people are generating fresh ephemerals. So I think to the extent to which you wish to convince your vendors to do this, you should be able to present them with some evidence that it's safe. I wouldn't imagine, for the reasons, given that the servers already do this, I wouldn't do part of this. Sorry. Just indistinguishable from this in the sense that they reuse the ephemerals. I wouldn't imagine that most clients are going to require fresh ephemerals on contact with the server. Certainly, I wouldn't expect NSS to do that. I don't think Boring's probably going to do it unless somebody makes it. Would you enforce fresh ephemerals ordinarily? Yeah, exactly. So it's a pain in the ass to do, so people probably won't do it. I guess, can you go back to your next slide or forward next slide? I think really the question is, what is it you're looking for here? I think, I like DKG, we like to put this in the main specification. It seems to me that what you need is a thing to point your vendors at that says, please make your TLS stack behave this way.
Ideally in a way that's been vetted by the right community and with
So,
the community.
right, so I guess that's sort of the question I was going to ask is, you have a document which no doubt could be buffed, and it could have some security analysis, which no doubt someone can provide you, though you'll no doubt have to get someone to actually do it.
Sure.
What is the, certainly you could have an RFC on this by simply submitting an informational series or something like that, right? So I guess, what is it in fact you need to get your job done from a document sort of stamping perspective?
So again, so just to be
Would
clear,
that, if you submit an informational draft that had that and a paper by Matt Green saying it was okay, would that get your job done, or would you do something else?
So to translate that, there are multiple ways to get to be an RFC, right? Through the working group, directly through an AD, and through the independent stream editor. And there's like a couple of others, but they're not really open to this because you're not on the IAB or all this stuff. So that's basically what he's saying about like which stream.
Yeah. So I mean, ideally, the TLS working group would help come up with the right consensus on how you would handle this type of a problem in this type of an enterprise. Again, we're not alone. There are a lot of enterprises that are faced with the same thing, and we'd come up, the RFC process that way, ideally.
Right. Yeah, and I guess, the reason you're seeing some reluctance, I think the reason you're seeing some reluctance in this room is this mode is worse, right? I mean, there's no question this mode is worse, right? And
which is again why we would only want that to be used internal to internal to the network, not ever out on the public internet.
And to be clear, Matt's draft is definitely not glossing over that part of the security.
No, I don't disagree. I don't disagree with that. I guess what I'm trying to figure out is, like, it sounds to me like you don't think an RFC number is enough, because you can have that for more or less for the asking, and so I don't know. I guess another possibility that I guess I said to Stephen Witter earlier is you might consider taking this to X9, who I think is generally more sympathetic to this kind of shenanigans. I think so. So I guess I'm just trying to figure out what gets your job done.
Daniel Franca, Akamai. So following up on the earlier question when you were asked about just logging ephemeral keys, you noted that while you have hundreds of application servers, that means hundreds of ephemeral keys to keep track of. But if you have hundreds that means you must already have hundreds of ciphertext dumps to keep track of and hundreds of server private keys to keep track of. So why does this really represent a big marginal increase in complexity?
I think, do you want to answer that?
Right, RSA private keys are a limited quantity. Ephemeral keys are hundreds of thousands, millions, right? Lots of SSL sessions happen. So the scale is way larger for ephemeral keys than for static keys. Does that make sense? I'm not a cryptography expert, by the way, so don't expect total expertise.
So just if your concern is just volume of data, then you already have the entire packet cap. So you're just adding a 256-bit key on top of that.
Yeah, I don't know that volume is the problem. It's the complexity of keeping track of all of them through thousands of servers and millions of sessions. Yep.
Can I add one thing to that? Because I share your problem. It's also going to be matching them up for points in time when you're doing diagnostics, and I think that's going to be a horrible nightmare.
Yeah. And again,
Mike
to
Ackerman
the
from
earlier
Blue Cross, sorry.
point. Sorry, could you say that one more? Your name one more time?
Mike Ackerman from Blue Cross.
Thank you, Mike.
You're up.
Nalini Elkins, Inside Products. One thing that occurs to me is that it's something that happens with a lot of different things. You know, IPv6. You know, I see it happening with internationalized domain names. You know, email addresses. I mean, all kinds of stuff where there's you know, cut over periods, you know, where you have, you know, zero, you know, flag days where one thing changes and then something else has to occur. If there's a lot of operational problems for a certain group that are going to be created, I kind of feel like maybe it's incumbent on us to put a little bit of work into, you know, helping these guys out here. And if you see it in some ways as a transition mechanism, you know, this whole thing with static DH, it's because I think, you know, of course the servers can do it. And yes, you can go through the independent stream and get an RFC number. But it's going to be a little bit of a struggle anyway, figuring out all the different OS manufacturers, crypto libraries, et cetera, that need to be changed. So I guess maybe having a draft for this kind of thing, which we all look at and has a really good security analysis, and which we've thought about. You know, I just wonder if that might be good, because, you know, boy, you just don't know what's going to happen in the next few years. Maybe in 4 or 5 years, we all learn something super new that changes the way we think about everything. But them, you know, people like them and a lot of other people have huge amounts of infrastructure they need to change. No question that PFS is the way to go. It's just, you know, how quickly can people get there? And, you know, sometimes it's a little slower, you know, for some people than others.
All right, we're going to clip the line after Kathleen, I think, is there. Or Dave, you're going to get in the front. Can you slip in front of Kathleen somehow? Is that all right, Kathleen? Subodh?
Hi, Subodh Iyengar. The current version of the spec already has like a way to do non-forward secure encryption, like out-of-band PSKs, for instance. So you don't really need to change the TLS implementations to always generate a static Diffie-Hellman key. You could apportion like the PSKs and schedule them into machines based on time, like so that diagnostics problem. So the PSK is based on time and some other secret which is rotated eventually. So you could have a smarter key schedule. So there's other ways to accomplish this without having the TLS implementations change with even the current RFC. So why would that not be practical? I'm curious to hear your concerns about that.
I don't think we've explored that.
Okay.
That's a fantastic suggestion.
DKG, you want to go before or after?
No,
Yeah.
It's DKG. So there are other mechanisms as well that would that you could use to not actually have a single static key. So sorry. The first thing I wanted to observe is that there are other mechanisms that exist right now where when you have repeated machines talking to one another, session resumption is going to cause non-forward secrecy, right? Because there's session tickets, particularly in the use of session tickets. Your data is actually decryptable as a result of the session ticket cache, right? So if the key in 1.2 and also in 1.3, for as long as you retain the keys to your session ticket cache, then all of the traffic that was used to flow across that one resumed session is decryptable. So forward secrecy is not a binary thing. It's a continuum about how long is your session forward secret for. So if you're going to approach anything like this, you should be clear about what the window of forward secrecy is that you're achieving.
Great point.
And make sure that you are minimizing that window as much as possible to reduce the size of the attractive nuisance that you maintain.
Absolutely. And yeah, and we could do that separately internally versus externally. That's interesting.
So I'm Debbie Cooley from NSA. So I think you need to look more closely at your architecture of your data centers. Use your man in the middles intelligently, right? So see if you can't encapsulate things a little more closely, a little more tightly, right? And then you can use the static Diffie-Hellman, or actually the PSK option is a very good one. Again, you don't need a separate RFC if you go that route, because it's already in TLS 1.3.
Sure.
You need an evaluation. So you need somebody to look at this and say where your holes are. You may be considered to be critical infrastructure. So there may be a place you can go to get an evaluation.
Thanks for that. Duly noted.
Don't know.
At nsa.gov.
Sorry, so perhaps I should have said I'm NSA IAD, right? So yeah, I mean, and anyway, that's my 2 cents.
Thank you.
Hi, David McGrew. So I wanted to ask about the details of what would a TLS server do in your environment. So if I understand right, you're asking for the use of static Diffie-Hellman on the server side. So you have, I think you said 400 TLS implementations, TLS server implementations, something like that.
On
hundreds
that
of them?
one application.
Something like that.
And
So
there's about 1,500 of those.
that you would be asking the implementers of those implementations to add a knob to turn on static Diffie-Hellman, plus a way to export it in some sort of format that would be
Something
standard
like
enough
that.
that it could be imported somewhere else.
Right, something like that.
Yeah, so I think we need to be conscious that we don't want to encourage knobs to turn down security that could be misused, right? And I'm very sympathetic to, one, running a data center correctly, and two, making sure that data is not being exfiltrated out of it, right? Which is a really serious concern. But at the same time, I think, this group needs to make sure that, our recommendations, don't provide a knob that, would be misused by other people not in this room.
Sure.
All right, Kathleen's baton cleanup.
Kathleen Moriarty, Security AD. So first off, thank you very much for coming and for presenting your problem. We do need customers to be part of the process. And, from what I've seen on the list and in this discussion, you guys have just gotten a ton of help. And I really hope that the expertise shared with you hits home. Otherwise, a lot of I don't have a US bank account, but I think people who do might be jumping ship at the moment who are in the room.
We're just an example.
Now, yeah, so let's see. Hitting on the last point that I guess feeding off of David McGrew, wiretapping, we have this RFC 2804. We don't agree with wiretapping, right? And this fits into that. However, you look at RFC 2804, we do think it's also good to document when you do find loopholes to that, right? But it doesn't need to be a full RFC. It doesn't need to be a standards track RFC. So ISC process that Sean mentioned can be used for that. So in looking at Matt Green's draft, it is fully baked, but listening to some of the discussion, so it's baked enough to be published, right? So from an IETF perspective, but if you're looking at like some of the architectural decisions and some of the modifications that could be done, like DKG was mentioning, maybe we could, if he's willing to help on that, on an ISC stream to get some of these things documented, that might be one route. I don't see this going standards track in the TLS working group based on prior decisions and consensus from the working group. You don't need an RFC even to use this technique, right? You could just go and do it.
Understood.
Let's see. I had several.
And it also sounds like there's some other options that we hadn't considered before that we'll take an action on after this meeting as well.
Yeah, so ISC, as Sean mentioned, it's not a standards track. It's just you can publish what you want to publish, and it doesn't have IETF consensus. And that is an option. The other thing too, you should know, when I looked at your examples here, and the example given on password, I had given this feedback back in Berlin. That is just an example of really poor logging. So one thing we are trying to do in drafts as they come through to final publication is if there's not enough logging in drafts, we're noting that and we're asking that logging be increased, because we know we're moving into a more encrypted world, so you need other viewpoints into the problems you're describing. I also have a very strong incident response background. I've been a CISO multiple times at some organizations that are very capable of that. And there are I won't go into, basically there are lots of ways to do your detection with encrypted traffic, right? So I see some of your points, but I think there could really just be a shift in a number of the things that you're doing away from needing decrypted traffic. And it does take time and expertise to do that, but I think you could lessen your need to decrypt as well.
Thank you.
So
I don't know, chairs, did I miss anything?
no, I think I think we're gonna wrap this up, and basically at this point, I think it would be premature to ask for working group consensus to adopt the draft. I think you probably wouldn't like the answer because Stephen, who's our other AD, hasn't even said anything because I guess he just got offline. But I do think that at least dialogue is open. People have started to converse. There are other options, and that you guys should continue to keep coming and interacting, because that's basically the only way we know is when you scream ouch, and that's what we need to do. So I want to thank everybody for keeping it classy. So
Thank you.
that's great. Yeah, thanks. All right. Yeah, so next I want to do Martin Thompson's no slides examples draft. Sorry.
I too have hex dumps. No, it's TLS 13 something.
It'll come up.
Vectors or
We
something.
have the internet.
You also have the working group page. You can just go there.
Yeah, well.
There you go, right there. Done. So I updated this yesterday. Finally landed exporters in NSS, and I think they're okay. This will help people test that. So I put a private key in an RFC. Anyone who wants it, it's
Example.
here. It's also up on GitHub.
It's an example. Don't use this in public. Don't use this on the internet.
Don't use this. That's actually the entirety of the security considerations for the document. Don't use this private key. It also mentions that it's 1024 bits, which is about the smallest that we can possibly accept with all the cranks turned down. The rest of the document looks like this. And if you keep going down, you get blocks like this. Well, look at that padding extension. Yeah, nice. Keep going, and you just get this on and on and on and on and on and on and on. Should we adopt this?
So my only point is that this is an awfully short examples draft, because I think Jim did an SMIME example draft that was 158 pages. Klaus Hoffman.
So
sorry.
this has 2 handshakes in it, and it's 28 pages already.
Okay.
I've had a request to add 1 more handshake, which will, another 14 pages. Thank you very much. If anyone has any ideas for what, Hannes,
another 14 pages. So
there is PSK in there, because the second example is 0 ITT, so it has PSK, but it does still do the X25519 key exchange with that handshake as well. Okay.
Eric Scrolla, do you know what a living standard is?
Isn't it called a wiki page?
Let's make this very, very clear. If anyone wants to do this sort of thing, they can go to my repo, compile it, run a different unit test by tweaking the draft, and they'll get a different set of output, and they can test all those sorts of things. We've got tons of test cases. I did realize when someone asked for P256, we have the embarrassing omission that we don't actually have any good P256 test cases, because we recently switched to 25519 and forgot that we need to add extra test cases in the process. Oops. But otherwise, this is merely for posterity and for making people's implementations lives easier.
I mean, thanks for doing this. Clearly, this is a good idea. I guess I think that the question solely is a matter of, is it useful to publish in the RFC series or people refer to? And I'm sort of ambivalent on that topic. I think on balance, it probably is good. But you know, I guess in terms of adoption, you know, I think, you know, I guess what I would ask is, why don't you would you please maintain this until we hit, you know, proposed standard, and then we can publish it in RFC then, and whether it's adopted as a working group item or not. I mean, you know, like, we're not going to really work on it. We're just going to stuff it in the document and publish it in RFC, right?
So if we were to adopt it, I think that would basically be what would be happening. We would like leave it paused. When we actually get done, you crank the thing again, we fill some things in, and we're done. There's not a lot to debate. Whether or not we'd have use cases or like how many we would do, that would be fine. But I mean, we're supposed to be developing interoperability standards, or for once, we're actually doing something that's getting deployed. So if this helps, we got to support that in every way possible.
Yeah, certainly. So I think, you know, I mean, I guess I hear, I guess, so on balance, I think we should put it in RFC. And my reasoning is simply that, you know, if you link it to GitHub, then, which is the alternative basically, then, you know, then when we're looking at it, you know, people are like, that GitHub goes down and it's lost. So I think we should publish an RFC, we should ref it out of, you know, 9346, whatever the hell it's going to be.
Sure. So one thing is, it's very easy for me to add unit tests, and probably the only thing that I would use working group input for is deciding which unit tests to write and which ones to include in the document. And currently I have one unit test. And working group input on which ones to use would be probably the I guess the main thing to look at. Yeah.
All right. DKG?
So anyone who's interested in this, this actually runs under CI, and it compiles NSS and runs the unit tests and builds the doc all at one time. So you get a different doc every time because we don't actually fix the keys.
So this is DKG. Thanks for writing this. I think this kind of concrete examples are really useful. I'm not convinced that actually having it in an RFC is the most useful way to do it. And I confess I haven't read this draft. So
someone's going to tell me that like bit 700 is wrong. At some
it happens. Point. It happens. But so actually, I'm not sure if you have intermediate results. That is this just wireframe? What's on the wire?
No. This is intermediate results. The whole point of this is to capture primarily the key schedule. So if you scroll up a few pages, you'll probably see an HKDF. Sean, can you give us a few pages in the middle of the hex? Yeah, so you'll see here when the client calculates a finished. I don't know which one it is because I don't actually have that in the logging, but we can fix that. And it shows you the PRK and the info that goes into that. And
excellent.
And all those sorts of things.
So this is great, but I think what we need to do is to actually go to, I don't know if it's RFC editor or who within the IETF, but if our concern is that GitHub might go away and we consider the RFC publication process to be more stable, we should encourage additional fate shared. Fine. We should encourage additional ways that we can publish useful repositories of this kind of stuff. This data, extracting this data is not going to be a fun job for anyone.
We'll let our IAB person get up and get the microphone.
Sorry, but like, if the goal is to have this stuff be useful, it would be way more useful to have many more copies than just this one. And I don't want to read, no one's going to read the 100-page document, and no one wants to extract this stuff from the document. They want to pull it from a tarball. So we should be hosting tarballs of test vectors. Come on.
Joe Hildebrand cutting the line with my IAB hat on to respond to your suggestion. So yeah, it's possible that we could do that. It's also possible that we could just decide that having effectively normative references to GitHub is okay. And I think that we could have a conversation about both of those things, and I think we should. I would say let's start with sending a note to RFC interest which is there's a mailing list where we talk about this stuff, RFC-interest, and let's get the conversation started.
So I think we do have an RFC that was published with Tarball. It was one of the codecs, right? I mean, we could just, he's in line, sorry.
Hannes, so it was before the Berlin IETF meeting when I struggled a little bit with the key derivation function, and for those, specifically for the DLS 1.3 use of the HKDF, I think having desk vectors is really useful. For some of the other things, like we see here on calculating finished and so on, it's probably less so, but I think having a few test vectors, even in the DLS specification itself, for the main building blocks, that would be useful, because if you mess this up, like everything else will fall apart. And in fact, at one of the hackathons, we had put test vectors together and shared them among the group, because that was the problem.
Yeah, so I think probably more to DKG's point, the best value you get out of this is interop testing. Like, you get the best mileage out of this, but this does provide a great number of test vectors for someone to extract if they wanted to do this. And most of the time you get it right on one of them, and you test it with a bunch of other ones. And so there's however many iterations of HKDF in this document that provide different combinations and permutations as used in TLS, that you can rip out and test any one of those. And you can then test again once you get that one working with one of the other ones. I think that's probably the extent of the value that someone's going to get out of it.
Richard Barnes, I'm sort of on the ambivalent train here about this, whether it's useful to put it in the RFC series. I think if we do, we should think a little bit about how to make it kind of automatically processable, so that we can have multiple stacks produce things for comparison to make sure that bit 743 isn't wrong.
I'm kind of dealing with the limitations of the format. I can produce any shape of output that is possible.
That is 72 columns wide, yeah.
Well, I mean, I could not produce an RFC and produce a tarball in the same way. Just name the format. I can do PCAP
So Colin, Jason, I mean, don't get wrapped up in this. This is all crap. I mean, I published documents that we stuffed the tarball in the back, and a link to the GitHub repo where you'd get the actual information you wanted. And I published ones where you encoded examples. There's a bunch of these in there. No one cares. Just throw them in. Don't bother discussing it. You don't need any new process. Just do it. The important thing is the link to where the GitHub repo is. But the reason that I think it's very valuable to publish these actually has nothing to do with them landing in the RFC editor queue. It's the process that every single time we went to publish one of these things that we thought was perfect, and we knew was perfect because it interopted and it was generated from an implementation that interopted, it turned out it was wrong. And it's the review process of going, this one right here is the golden copy, whether it's in GitHub or not. It was the choosing the golden copy and you know, blessing it, right? That was the important process. It didn't matter where or how you publish it. So, and I think these examples, I mean, I was trying to implement TLS on a very constrained device, and like, boy, I would have really wished I had things like this to check what, yes, I knew my thing didn't work, but which stage along the 22 steps did it go wrong? This type of stuff is so valuable, particularly when you're, you know, implementing without really understanding how the specs work.
So this topic, this got a lot longer than I thought it was going to, so I'm going to clip it after Dan, the line. Oh, go ahead.
Yeah, this is great. This is great. This is great. And RFC is way much better because we've got, you know, a tarball with a bunch of files isn't going to work on all the platforms we have anyway. The simplest way I'm going to be able to test this in OpenSSL is to cut and paste and then dump it into whatever my tooling framework is. So in that case, just put a new line after the colon so I can just seriously, right? So I can just cut and paste lines.
Speaking of limitations of tools, that one may actually be quite difficult. I can work with that.
So, Dan York, I was waiting for when Cullen stood up here and talked. I was just going to emphasize something that in what he was saying, which is that going through the RFC process forces people to actually read it and get a higher level of review. Because we had tools, and Cullen and I were saying about in the SIP side of things, we had different test suites and stuff that were in wikis, and people were not necessarily maintaining those or you know, making sure that they were up to date. So I would say the publishing process is good for that regard, that it does enforce the discipline of making sure people actually check all of it. I think it's great that you're doing this because I think anything that helps implementers provide, because we've seen that with other folks who have been saying, how can I know that my product really does all the things that it does? So it's good stuff, I think.
All right, so what we're going to do is we're going to, sometime early next week, take this to the list for working group adoption. If there's anybody that thinks this is a really stupid idea, you should get to the microphone now.
All right, let's sit down. Now, this is a special opportunity.
Yes. All right, cool. So
Come on,
we're
bring it.
going to take it to the list and everybody can comment there. I think this is pretty straightforward. Next, we're going to have Nick up for exported authenticators, and then we're going to have Hannes. Do you have TLS 1.3 slides or not?
I did not send them.
You did not. You sent the optimization stuff, so just make sure you send it to
Send it to you.
yes. Ta-da! As my computer slowly drags its way through this thing. All right.
Okay, hello everybody. Thanks for having me. I'm Nick Sullivan. I work at Cloudflare on TLS related things. I'm presenting to you a draft that I wrote up that is actually relating to other drafts in HTTP, but it's called exported authenticators. Next slide. So this is a new concept. We have the concept of exporters in TLS we've had since RFC 5705. But what exported authenticators is a sort of a more complex or a more meaningful exporter that allows you to take a TLS connection and bind it to a certificate, and you get a resulting output that can be transported in other layers. The motivation for this is the idea of HTTP2 secondary authentication, and I'll go into that in a second. Next slide, please. So for some background, client authentication in the first step of the handshake has been part of TLS for a while, but in many applications, there's a need to actually authenticate the client after the TLS connection has happened, sort of reactively to someone going to a subdomain that requires some client authentication. And in TLS 1.2 and before, this is done by doing a renegotiation. Renegotiation has been removed from TLS 1.3, and it's actually a little bit disruptive when it works very well in HTTP 1, where you have a very distinct request response flow. You can do a renegotiation after that and continue with your next request. But in HTTP 2, things are pipelined, and actually halting the request of the TLS layer is slightly disruptive. So there's a proposal to add the ability to do reactive client authentication in the HTTP layer, but in doing so, you have to actually validate the certificate and send that certificate information somehow. Next slide, please. And that's one of the motivating pieces for this exported authenticators work. The other is HTTP2 connection coalescing. So right now, if you have an HTTP2 connection and as what the browser will do is if it's connecting to a new domain and that domain has the same IP as the original connection, as well as is covered by the same certificate, meaning it's in the subject alternative name list of that certificate, it'll reuse the connection. And this connection coalescing is actually very good for performance in a lot of ways, but requiring the same IP and requiring a certificate with multiple subject alternative names is not as broad as it could be. There are a lot of services, Cloudflare included, and CDNs that manage multiple domains, but don't necessarily operate those domains on the same IPs, or don't have certificates that cover all of these domains. And it would be a very nice experience in HTTP2 if you could coalesce connections across all of these different domains and be able to sort of use the same TCP stream for them. Next slide, please. So there were a couple attempts of how we could do this. The first of which was in HTTP2, where all of the crypto was sort of built into these extended frames. This is a draft by Mike Bishop and Martin Thompson that was presented, and this is something that's going to be talked about at the HTTP BIS workshop. But the original example, or the attempt that we had from doing all of the crypto in HTTP2, it was suggested that we move this up into the TLS layer. So being able to, after the fact, take a certificate and authenticate that certificate on a connection after the original connection from either the client's perspective or the server's perspective would be a way to add additional certificates. And the original proposal, this is something that I submitted a couple months ago, sort of followed exactly in the post-handshake auth flow of TLS 1.3. So it started with a certificate request, and in this case, a potentially optional certificate request, followed by the certificate verify, and finished. And all of this using the handshake context as defined in TLS 1.3. So this is kind of a superset of what the existing post-handshake auth is. So in the current post-handshake auth, you can do a certificate request from the server, and the client will respond with certificate verify finished if it has a certificate of this type. This is sort of extending that to cover all different orientations in terms of client requested, server requested, or spontaneously from the client to the server or server to the client. Next slide, please. This turned out to not be, from speaking to a lot of implementers, not the optimal way to do this. One of the problems is you have to acknowledge the certificate request with a finished message in all cases. So this allows the client or the server, in whatever case, that are receiving these certificate requests to build up a queue. They have to manage this queue, and this is something that came up in the key update conversation as well as something that's not optimal for implementation staff to take care of. Note that this criticism also applies to the current post-handshake authentication piece, but as it applied to the current post-handshake authentication, it also applies to this kind of extension of it. Next slide. So the idea to help solve this is to not actually send this post-handshake authentication as part of the TLS stream. It's to rely on some external transport, be it the TLS stream itself or some other way for the client and server to communicate. And essentially, what happens is these post-handshake messages, rather than being sent, they're exported. Next slide, please. And this is really the diagram of how it would work. So your application in talking to TLS would send to it, we start in the top left there. In your layer 7 application, whatever it is, HTTP2 is sort of the example that we're working off of here, would send a certificate request or whatever, something analogous to the certificate request in TLS structure from one side to the other, and this certificate request would go into the application layer. It would choose the correct certificate that matched that request and the key, and call into this new API, into TLS, that says, okay, give me a certificate proof from this certificate. And it would create the certificate verify, and finish message that would have been used in the post-handshake authentication, and export it, or something very similar to that. It's basically a proof that this certificate, that the client, or the server in this case, has possession of the private key associated with that certificate, and it is bound to the handshake and the TLS context. And then this output, the certificate proof, could be just sent back along, in the case of HTTP2, in a specific HTTP frame, but through an encrypted tunnel from the client to the server, or the server to the client in this case. And this certificate proof could then be sent back into a TLS API to validate that it actually, yes, it matches this TLS connection, and the signature is correct, and the finished message, which is essentially an HMAC, is also correct, and that would return the certificate, and then you could pass that up to the HTTP layer, and from there say, yes, this is an additional identity that can be added to the communication layer, and this would allow you to do both of the scenarios that I talked about before, where it's either a client authentication, post hoc client authentication. You can do this flow. The server will say, hey, give me a client identity that is valid for this CA. Or if servers wanted to add additional identities to the TLS connection, they could do so spontaneously at any point. Even without the certificate request, they could just send a certificate proof, and the client would be able to validate that and add it to the connection. Using this exported authenticated mechanism means that you don't have to actually send messages in the TLS message framing layer. So you don't have to deal with actually queuing these things up. It's really independent of that. It's just a simple API of create me a proof or validate my proof. Next slide, please. So one thing that came up in discussion of this is we don't necessarily have a formal security proof of this yet. In the post-handshake client auth mechanism, Hugo Cross's SIGMAC paper sort of showed that this was valid, and this is something that actually does give you the security parameters that you want. But from the secondary server authentication, we don't necessarily have a formal proof of this yet. People seem to think that it's okay, but we don't have the math to back it up.
Nick, do you know the people to engage to get that formal analysis? If we were going to do it?
Yeah, most likely we'd try to talk to Hugo.
Okay.
See if he would do it. Otherwise, there are a bunch of other people in the academic community who could help look into this.
So just to expand on that, Martin Thompson, the intuition here is not as simple as it seems. So the Hugo SIGMAC paper was talking about a compiler that took a unilaterally authenticated connection and turned it into a mutually authenticated connection. Now, this is a case where you're adding to the same side as the original unilateral authentication, which in some respects changes things dramatically. And so there's a number of questions around what is the nature of the primitive that we're actually providing here, and who's mutually authenticating whom, and all of those sorts of things. And there is nothing in that basically that's applicable to this, other than there may be some techniques that we can reuse.
Right. Yeah, I'm not claiming that this is secure, or there has been a security analysis of it, but yeah, thanks, Martin. And there's also just the question of these are tied, just as authenticators are, to the original handshake. If you're doing key updates, you're not necessarily updating the keys used for this. But those are the current open questions. And next slide, I think this is the end. Yeah, open for questions.
Could you go back one slide?
Sure.
So as I understand it, the HTTP application initiates the certificate request on the HTTP layer in your proposal.
That's correct. This is an example of a use case.
I'm wondering how this affects the state machine of the zero RTT data. For example, in TLS, we don't allow, when the server accepts zero RTT data, we don't allow it to send a certificate request to the TLS layer. So what if the application gets an HTTP request, which is actually zero RTT HTTP request, and then it sends a certificate request on that zero RTT response in the 0.5 RTT data. Oh, the 0.5 RTT data, yeah. So what exporter does it use in that case? And it's a weird
yeah. So we would assume that we're using exporters from the finished handshake. So the handshake would be complete. So in the case of, this is also going into the HTTP draft, so I don't necessarily want to cover that too much here. This is just an explanation.
Yeah, my question was more about do we need a new API to tell it that this data is 0.0 RTT and you cannot do this? Or are you going to allow it to be?
I would say that's just a general question with zero RTT data for TLS. what type of application data you can send in 0RTT. And I would say when it comes to HTTP2, if you have non-idempotent data, then that probably should not go into the 0RTT data. And if you have data like this that's potentially cryptographically unsound to send it in 0RTT, you probably shouldn't include it.
I see. So do you want to allow this only for 1RTT data, just to confirm? Sorry.
It's outside of the scope of this.
Okay.
But yeah.
Yeah, Daniel Franca. Sorry if this is slightly tangential to your talk, but is anybody working on an RFC 5705 BIS to cover TLS 1.3? I was just going through that draft and I noticed that it explicitly references the TLS 1.2 PRF, and since we've changed the PRF for 1.3, I think a BIS might be in order there.
Oh, yeah. So to answer, the question is there a BIS for the exporters? And it's really been incorporated into the 1.3 draft.
Right.
Exporters.
Thank you.
Hi, Jeff Hodges. So this is happening at the app layer, at HTTP layer, right?
The transfer of the data is handled.
Okay.
At the HTTP layer, yes.
Okay. So when the app layer calls into these postulated APIs, does that change the state of the TLS stack?
No, it does not. So this is completely stateless in the TLS stack.
So you're really not adding a notion of an authenticated identity to the TLS stack at this point. This is all happening at the TLS, at the HTTP layer.
Right. You're taking an identity and binding it to
the
TLS layer, or the current TLS connection.
Okay.
And providing a proof of it through this export.
Why do all this? Why not use token binding to just bind whatever the app is sending across at the HTTP layer to the TLS channel that way? Why go through all these extra machinations of certificate messages and verify and finish messages? Sure. I mean,
Martin, you want to step up and explain?
So, Martin Thompson, the fundamental issue here is that we have a multiplex protocol sitting on top of TLS here, and whether that be QUIC or HTTP2, and you need to be able to bind this authentication that's going on into a particular request, and being able to identify which request this authentication is talking about, or which application level construct this authentication is associated with, is important. And one of the problems with doing, say, renegotiation in HTTP2 is that you can potentially have many requests outstanding, and you don't know where to throw. Say for instance, you've got a browser with 10 tabs open, and all those 10 tabs are going over the same connection in H2. When one of them triggers an authentication request, which one do you show the certificate request prompt in? Which browser tab are you going to show that in? These requests are made in some sort of application level context, and you need to know which one of those contexts you're in when you make that request so that you can service it correctly.
It's really about
we don't need to go. Yeah. Okay.
So there's something that I didn't really cover in the explanation here, which is that the HTTP layer, when you're actually creating this certificate proof, you can bind it to an identifier, and you actually necessarily have to bind it to a unique identifier per connection. And that's just one way of linking this multiplex layer on HTTP to a single event on the TLS layer, if that makes sense.
Yeah. Okay. So basically, there's more complexities here as driving the design than are necessarily clear. So from the presentation.
Right.
Yeah. And yeah, I apologize. I haven't read the draft. But okay.
Ben Kadek, I will apologize. I did read the draft, but could you remind me, is this
using like the finished hash over just the initial handshake, or is it signing an exporter value?
It's using the finish hash over an exported value, then the certificate and the certificate verify. So you have an exporter as that acts as the handshake context,
right?
And then the certificate verify, and your HMAC is over those three. The finish message hash, I should say.
And then I was also not quite entirely sure I understood the motivation. So you mentioned this use case where like you have a single server that is serving multiple things, but it doesn't have like a single cert that has subject names for all of them. And so you want to be able to let it serve all the traffic on a single connection instead of having to meet multiple connections. And that sort of makes sense. But you've also got this scheme for the client authentication in there, which is there another use case for that you have in mind, or are you just putting it in because it's symmetric? And
so I can.
Mike can answer this.
Yeah. So actually, Mike Bishop, Microsoft. I'm the author of the HTTP draft. It actually started as client auth because client authentication has been done with renegotiation. HTTP 2 prohibits renegotiation. And we're running into use cases where we need to do client certs somehow.
Right. Oh yeah. So Martin was just talking about this.
Right.
Yeah. Okay.
So it started with client certs, and then there was just this harebrained idea that, hey, we could do it for servers too. And that actually has proven to be even more popular. And so we're trying to solve both in the same direction.
Sure. Yeah. I was taking notes during the talk. And I was reading from them.
Andrei Popov, Microsoft. So there are aspects of this idea that I like. I think it puts the crypto work in the right kind of in the right layer, right? So you have the TLS code generate messages that prove possession of the certificate and such. That's good. It does allow the correlation between a request and a certificate, right? So that's what we wanted. There are a few limitations here. Now, previously what we had was the TLS state that the client, that the application could query. The TLS state contained all the identities available at this moment in time. Now this state is kind of distributed. Some of it is in TLS. Some of it is in the application, kind of. So those two things kind of need to be combined to get a full picture of the identities asserted by the peer. The other interesting consequence of this is that if in the past the TLS stack could use the available identities for things such as resumption, whether we can resume a connection in this case or not. Now it's not all of this information is available to the TLS stack, right? Unless the TLS stack is actually hashing all of it, caching all of that, all of the supplemental identities, right? That information might not be available. So there are some interesting consequences to this, but I think it does solve the primary use case.
Yeah, and I think what you mentioned there, the TLS stack being able to cache these identities, whenever you do the actual take the certificate proof and validate it.
I could in principle
store it there.
But can I, also in the past, I was able to generate, for example, a new session ticket,
right,
including all the identities, which in this case, I'm not sure, like.
You can generate a new session ticket.
I can still generate and it will be sent. Okay.
And put whatever you want in it.
Okay.
The decision as to whether you should resume with a PSK for a different domain than you originally connected on is another point that I believe that we'll be covering.
Okay.
So far, we have been presuming no.
Yeah, currently, yeah, I think Ecker can speak to that, but I think we assume that you connect on the same SNI, or SNI during PSK resumption has to be identical.
Clip the line here after Ecker.
Kyle Eckertz. So in the draft right now, these messages are sent in plain text at the application layer out of the TLS layer. Is there any reason why that needs to happen? And if not, could we encrypt those to basically enforce that the application isn't trying to do anything funny, look at them before verifying them on the other side?
Sure. the key that's used to create the finished message, I thought it was just simpler to not also encrypt, but to rely on whatever transport mechanism to send that. And these should be considered opaque, but you're right, they are not opaque to the application. They could potentially peek inside.
Mike, I think you're in line next.
I'm here because it's my related to my
Pondering, okay.
Right. So it seems like, I mean, my sense is that the client authentication part of this, like the details may need a tiny bit of tweaking or may not. I'm just having been through them completely, but like essentially is like no different from post-initial client authentication. So, it's like, the same shenanigans like that we've been doing the whole time. So, like, so that seems straightforward. It doesn't create, it may create cryptographic problems though. It sounds like what you're doing is reasonably sound, but there's no conceptual problems. It's the server thing that has the conceptual problems, as you indicated earlier. I think it might be helpful. So I think on one hand, we need to have, as you say, we need to have someone do analysis and validate what the apparent guarantees are. For what it's worth, it's not clear to me that the current design offers the guarantee that both sides agree about the exact set of clients certificates that have been offered. So I mean,
right, yeah.
So I mean, which we just apparently decided we didn't care about, but it may be more complicated if this on the server side. So it seems like the first thing to do is get some cryptographic analysis. The second thing to do, I think, is to let us assume the set of properties is a set of properties we wish it to have at the cryptographic layer, and ask are the application semantics we're comfortable with. And I think this goes back to Mike's draft too, which is to say we need to ask, how do we treat these new certificates? Are they on an equivalence class with the original certificate? Is it the case that, and I think you may have mentioned to me, just because, do I remember, if I did origin, if I glued all the origins together in connection 1, when I resume, can I assume the same thing is true in connection 2? Like, there's a lot of questions we'd have to address in order to actually make effective use of this technology in HTTP.
Yeah, I think that last question is something for Mike's draft.
I think so too. Yeah. So I mean, it may be the case that one simply says, well, these are the properties that TLS provides here. Like, what you make of them is kind of on your own, right? But given that, the rationale for doing this work in TLS draft was that we theoretically had the ability to analyze it, and probably the semantic questions do at least have some TLS, salience, right? So we probably do have to think about it a little bit. But
So all right, so to close this off, because we're out of time at this point, right? So my sense right now is it's maybe a little early to ask for working group adoption, but you seem like you're definitely on the right track. So my sense is that we should continue on getting input and as much as we can, and then in a month or so, or maybe like early next year, we'll get a sense of whether or not we can go ahead and go for working group adoption on this. But before I do that, how many people actually read the draft? You read the 0.0 version of this draft? That's fantastic. So that's great. So I think because I didn't hear a lot of your crazies, I think we're definitely on the right path. So I guess thanks. And to remind everyone, we have a session on Friday. There are things that we're going to talk about that you will care about, like DTLS and other things. So we're going to get somebody to do a proxy of Hannes, but we have other things to talk about as well. So we'll see you then. Thank you.
So we had just those like 3 drafts plus the status of the remaining.
I mean, that's arguably really important. So I hope people come.
Yeah, that's what I was thinking, to do that first, right? One, because it should be reasonably quick, I think. Of course, I thought some things today would take less time.
Lauren's draft is going to take that long.
Yeah, we can still get into that hard.
It was a nice break. Actually